Hey there universe! So a while ago I discovered this really cool web page. It was basically a web page which demonstrated the scale of the universe. I have no kind of brain for science. It's something that I found really cool, but I don't know if I'll be able to explain it properly to you, so I decided to get a friend of mine to help me out with it. So without further ado, here is my good friend Dr. Hubert Flamdigam. Take it away, sir.
Thank you very much, Mr. Kaz. I am deeply grateful for being allowed to talk on one of your videos. Maybe I can extend my gratitude by inviting you to one of my cool parties.
You don't have any cool parties.
One of my lectures then?
No.
Sleepovers?
No.
Well, I'm grateful anyway. So let's not waste any more time. Let's take a look at the scale of the universe. It's quite exciting. So to start, I have chosen something familiar. Us, the human race, who, according to the scale of the universe, is only 1.7 meter in size. Small, you might think, yes, but believe me, you're going to feel very small by the end of this video. So, as we zoom down on the scale of the universe, we can notice everyday things like eggs and Rubik's Cubes and cups. Small things that we might measure in everyday life, but we know are smaller than us, hence they must be smaller according to the scale of the universe. So I won't go into many more details about them, but boy would I like to. But let's get down to the good stuff. So, according to the scale of the universe, the smallest thing visible to the naked eye is 10 to the power minus 4 meters. That's 0.1 millimeters in scientific terms. I don't know which science, but it is a scientific term. We then keep going down and see things like wavelengths and red blood cells and droplets and HIV. That doesn't look nice. But there are cool things like the strands of DNA, which are only 3 nanometers, or a carbon atom, which is only 70 pictometers. That's 1 millionth of a millimeter. That's right. Yes, I discovered that myself, actually. So we pass through the many different atoms and the wavelengths. Now you might think those things would be the smallest things in terms of the scale of the universe, and there were many scientists years ago who believed that. Sadly, they were wrong. Why? Because they were idiots. If you go further down the scale of the universe, you will be able to see the size of what is inside an atom's nucleus. Boy, would I like to see the inside of a woman's nucleus. What? I didn't say that. We then carry on through the many electrons and protons and neutrinos and quarks until we reach the tiniest things ever in terms of the scale of the universe, which are basically the building blocks for our universe. It's amazing how small things can be put together to make a big thing, like Lego. So these things are the quantum foam, which is basically the fabric of Einstein's space-time theory. There are also the strings, which are part of the string theory. All of these are at a Planck length.
Planking?
No, not planking, that's a silly, stupid ritual. Basically, Planck length is measured at 0.0000000. No, screw it, it's 10 to the minus 85 meters, which basically means anything tinier than a Planck length makes no physical sense. So technically it doesn't exist, so I don't know why we're making such a fuss about it. I've got better things to do with my time.
Like what?
I'll get back to you. But enough of the tiny things, seeing as how we have reached the limit of tiny things. Let's take a look at the things that are bigger than us in terms of the scale of the universe. So there's the usual expected stuff that are bigger than us. There's giant earthworms, houses, buildings, skyscrapers, all those nonsense things. But an interesting discovery, it turns out a lot of the moons that surround some of the planets in our system are actually smaller than the United States of America. Typical Americans. And so we zoom further out and we notice our planets that are in the solar system. We go further out and there are the stars that make up our Milky Way galaxy. We also come out to our nebulas, which are basically interstellar clouds of dust and various gases. But don't be fooled by that, they're actually quite pretty. We can also see a nebula known as the Pillars of Creation, which technically doesn't exist anymore, but because of the whole light year thing, we can still see them. So we've still got a good couple thousand years of seeing that. As we zoom further out, we notice the numerous galaxies that make up our galactic group, including us, the Milky Way galaxy, named after, of course, the famous chocolate bar.
No, it isn't.
Ah.
How is it you're still a physics professor?
I don't know, maybe it's because the dean has a crush on me.
Your dean's a woman?
No. Anyway, we then reach the limit of our observable universe, which is of course 14 billion years old. Everybody knows that, including you.
Really?
Well, no, not you.
Oh.
Anyway, so if there was something 14 billion years away, it would take 14 billion years for us to actually see it, which would take longer than the universe has actually existed. And then of course, we come to the absolute end of the universe, which is 93 billion light years away. Whew. It took ages to get there. So that is it, the absolute scale of the universe. I hope you enjoyed this presentation, and I please welcome you to come and join my many lectures at the Bromley Tech College.
Don't do the thumbs up.
Okay, I'm sorry. So, should I just go?
Yeah, you should just go.
Right, thank you.
Okay, to be honest, my explanation on the scale of the universe might not have been any worse. But he was a friend and he was just like, "Can I be in any one of your videos?" And I hesitated and just said, "Okay, you know, the way it goes with your friends." But in all seriousness, that webpage is worth checking out. There's a link to it on the doobly-doo down there. Not in my crotch. The doobly-doo wasn't a euphemism, it's the information box underneath this video. Even if you're not a complete science nerd, you can appreciate it. Heck, I even showed it to Mr. Happy and he appreciates it.
Where's the porn? You said there'd be porn.
More or less. And now seeing how big the universe is, I realised, should I really be fighting it or should I be joining it? I'll leave you to comment. See you later.